Today's topic is to calculate the Woodward Fischer rule for alpha beta unsaturated carbonyls. Now you can see here this is the functional group, that is carbonyl, and with respect to this functional group, this is the first carbon, which is alpha, and this is the second carbon, which is beta. And in alpha and beta there is an unsaturation. So in this also we first of all we will be calculating the parent value. So acyclic or 6-membered ring, you will be putting the value 215 nanometer. For 5-membered ring, you will be taking 202 nanometer. For aldehydes, it is 209. In certain books, it is mentioned 210. For acid and ester, you will be taking 197 nanometer. So this was the parent value. Now let us talk about the increments. First, here also you will be seeing the ring residue and alkyl substituent, but here you have to mention at which position it is present with respect to the functional group. If it is at alpha, beta, gamma, delta position, you will be writing 10, 12, 18. Second is double bond extending conjugation. So in that you will be adding plus 30 nanometer. If your compound is homoannular conjugated diene, then you will be adding 39 nanometer. For exocyclic double bond, you will be adding 5. Besides that, if there are substituent or oxochromic group, accordingly you will be putting the value. For example, OH, if it is at alpha position, you will be adding 35. If it is at beta position, you will be adding 30, and gamma is 30 and delta is 50. Amines, for amines you will be taking value 95. For alkoxy group it will be 35 for alpha position. For beta it is 30, gamma 17, delta 31. For OCOCS3 it is 6, for chlorides it is 15, 12, 12, 12, and for bromides it is 25, 30, 25, 25. Now let us try to solve few examples related to this. So this is the example. This is the functional group. With respect to this functional group, this is alpha and this is beta. It is acyclic open chain compound. So parent value, in this case I will be taking 215 nanometer. Alkyl substituent, if you see here, 2 alkyl substituents are there in beta position. So for beta position, alkyl substituent value is 12. So here you will be taking 24. So you will be getting 239 nanometers. Now see the next example. Here also you can see this is your functional group. So this is alpha carbon, this is beta carbon. So one substituent, it is at alpha position, whereas second substituent is at beta position. So parent value I will be writing 215. So at alpha position the value is 10, at beta position the value is 12. So total you will be getting 237 nanometer. Now let us do for the aromatic compounds. For aromatic compound, the parent value in case of this group is 246 nanometer. If it is ARCHOaldehydic group, it is 250. If it is acid group, it is 230. If it is an ester group, it is 230 nanometer. Then you have to see the substituents. Substituents, they are present in ortho, meta or para position. Accordingly, you will be giving the value. For example, the alkyl substituent or ring residue at ortho and meta position, it is 3. At para position, it is 10. OH, OCS3OR, at ortho and meta position it is 7, at para position it is 25. Oxonium ion at ortho position it is 11, meta is 20, and para position it is 78. Chloride ions ortho and meta position it is 0, para position it is 10. Bromide ions ortho and meta position it is 2, para position it is 15. Amino group ortho and meta position it is 13 and para position it is 58. NHCOCS3 ortho and meta position it is 20 and in para position it is 45. NHCS3 it is 73. So depending on substituent, what substituent is present and what is the position, you will be writing the increments for the substituents. Let us solve numerical. Here the parent value will be 246 since it's an aromatic compound. Now let us talk about ring residue. Now with respect to this functional group, solve this example. In this case, parent value will be 246. Ring residue ortho and meta position, it is 3. So you will be writing 3. And here methoxy group is present. So its value is 25. So if you add all of them, you'll be getting 274 nanometers.